The virtual sensor concept, separating sensor software from the hardware. Existing remote water quality monitoring platforms are prohibitively expensive for most applications. Much of this has to do with the expense of the individual sensors. While these sensors are highly capable and sophisticated devices, the actual design approach taken in conjunction with the larger sensor network delivery system results in severely restrictive proprietary systems. In an aquatic monitoring platform, the financial costs of the sensors are threefold. 1. The cost of the sensor, the initial outlay. 2. The cost if the sensor is lost or damaged. And 3. The cost of the data if it is lost or corrupted. As the sensor software is integrated with the hardware, the calibration implementations are primitive and inflexible. There is no control over how the data is converted from raw values into meaningful data. Instead, the end user gets a series of processed data. In addition, functions such as the calibration coefficients and the sampling rate cannot be remotely altered. There are two aspects to calibration. The first is calibration under laboratory conditions against another device with a known accuracy. Or 2, validation of the sensor's readings out in the field. Once sensors are deployed in the field, they will start failing. This impacts the readings over time. Therefore, there is a need to periodically maintain the sensors. Figure A illustrates the traditional configuration for sensor devices and the calibration approach. A sensor device takes an environmental reading via its sensor. The calibration equation is then applied to the sensor readings based on the calibration data. The output is the calibrated sensor reading. The sensor reading, calibration data, and calibrated sensor reading are stored on the sensor device. In Figure B, we are proposing the virtual sensor concept. Here, the sensor heads are stripped of all calibration and communication software and return the basic data, which is a stream of bytes, to the communication chip, typically a basic processor, which then transmits this raw data back to a web server. No processing or any other manipulation of the data occurs on the sensor cluster. Any transformation to usable data occurs on the web server. The virtual sensor concept allows us to undertake dynamic calibration adjustment. If failing growth can be approximated, this will allow devices to stay deployed for longer. Via the virtual sensor concept, raw data can be used to statistically examine the correlation between different data sets. Statistical data models can be used to quality assure the entire data set. We applied this approach to calibration and quality assurance of turbidity data.